In 1.5, our goal is to solve problems using verbal models. That means we're going to be using word problems. Word problems are going to be a big focus in this course. So if you're not a big fan of them, try to change that viewpoint a little bit. They're not as bad as they look most of the time. The Acela train travels between Boston and Washington, a distance of 457 miles. That's a distance. Maybe we'll call that D if we need to. The trip takes 6.5 hours. That's a time. What is the average speed? Average speed is another way of saying rate. The reason I wrote these letters down specifically is because I'm looking for a formula that relates this stuff. If you think back to that page of formulas we saw a couple lessons ago, maybe it was last lesson, distance equals rate times time. It's a formula you need to know. So if we know the distance and we know the time, we can figure out the rate. We know the distance is 457 miles. We know the rate. No, we don't. We're going to find out the rate. We know the time is 6.5 hours. To figure out rate, we just need to divide by 6.5 hours. And when we do that, we'll see that we get 70.3 miles per hour. If you leave off those units, you're not quite right. That's what we're looking for, the rate, average speed. At this point, you can pause the video and try the guided practice on your own, or you can wait until later. Example 2, we're looking for a pattern. It says a paramotor is a parachute propelled by a fan-like motor. The table shows the height h of a paramotorist t minutes after beginning a descent. Find the height after 7 minutes. Notice the table does not give us information for 7 minutes, so we're going to have to look for some kind of pattern. You can pause the video and try to find the pattern yourself. The pattern I noticed was every step of the way it looked like we went down by 250 every minute. And we could figure out what happens after 7 minutes by just making the table go longer. But we're going to try to come up with a formula instead. That's more valid practice for Algebra 2. So I might say my height equals 2,000, because that's what I start at. But then I take away 250 feet every minute. So maybe something like this. T could be in minutes, as we see in the table. So after 1 minute, 250 times 1 is 250. 2,000 minus 250, 1,750. Works on the table. If we want the height after 7 minutes, we just plug in 7. And you should get 250. For your final answer, don't forget your units. We know this is 250 feet from the problem. And that's it. Again, you could have done this without making an equation, but it's always best to make an equation if possible in case you're dealing with big numbers eventually. Example 3, you're hanging 4 championship banners on a wall in your school's gym. For me, the first thing I'll do right then is draw a big rectangle to represent the wall of my school's gym. Just helps me visualize what's going on. The banners are 8 feet wide. So I know my banners are 8 feet wide each, and I know I have 4 of those. The wall itself is 62 feet long. I can put that in my picture. There should be an equal amount of space between the ends of the wall and the banners, and between each pair of banners. So what I'm hearing when I see this is all of the banners are equally spaced out, and that same equal space is on both ends. Which really sounds like I have banners going like 1, 2, 3, 4. And the problem's telling me that each of these distances has to be the same. So I'm going to use x to represent that distance. I've even got to have that distance on both sides between the wall on the first banner and the wall on the last banner. I know that each of these banners is 8 feet wide. So now I can figure out what it's asking. It's asking me how far apart should the banners be placed. That's really solving for x. Looking at my picture, I know that there's 5 x's plus 4 times 8 for the banners, and altogether that needs to equal 62 feet. Now it's a matter of solving for x, and I'll have my gap width. Once again, I stress, don't forget your units. In this case, I needed to put feet. There's 6 feet between each banner. Standardized test practice. A car uses 16 gallons of gasoline and traveled a distance of 460 miles. The car's fuel efficiency is 30 miles per gallon on the highway and 25 miles per gallon in the city. How many gallons of gasoline were used on the highway? So we've got to set up some variables. We want gallons of gas used on the highway. So I might call that X. I'll also need to know how many gallons I use on the freeway to figure out this problem. And I don't want to give another variable to that because I can kind of figure it out. I know I use 16 gallons total, and X of them were on the highway, so I could take that total 16 gallons and subtract the gallons on the highway, and that should give me gallons on the street. City streets. Now I can figure some stuff out here. We know we've got 30 miles per gallon on the highway. So let's put that 30 miles per gallon times gallons used on the highway plus 25 miles per gallon times the number of miles on the city. And our total miles ended up being 460. Setting up the equation is kind of hard. Once you've got the equation, you should be able to use your order of operations and steps for solving equations to get to a solution. Once you do all that, I recommend you try that on your own. Make sure you understand how to do it. You should end up with 12 gallons used on the highway. Done. At this point, you can try the guided practice on your own, or you can save those until later.